Alright, guys, so this is it. I assigned some homework for you. So next page you will see 3 different problems. Alright, so try your best and please do it and upload it. I will give you like feedback for that. So if you have any question, text me and please complete your homework. Okay, thank you for watching the video. Have a great day and see you tomorrow. Bye bye. Hi guys, so let's start today's lesson. So we will do inverse function intro today. So before we start it, I'm gonna review our function. So we did the function like a month ago, I think. So look, state whether the data in each table represents y as a function of x. Explain, right? So when the x value repeats, then that's not a function. So look at this. You have 5 here, another 5 here. So is that a function or not? This is not. So not a function. Nope. Right? And what about number 6? Is your x value all repeating or not? None of them repeats. You have same y value, but that doesn't matter. So this is yes. What about number 7? 10, 20, 30, 40. It's not repeating. You have same y value, doesn't matter, right? So this is yes. And what about 8? 3, 2, 8, 2. You have 2 same value, 2 and 2, right? So that's nope. And look at number 9. State whether each graph represents a function. Explain. So do you remember the vertical line test? Vertical line test. So that was, we draw the vertical line, and if there's only one intersection, then that's a function. If you have more than one, then that's not a function, right? So let's draw the line. Boom, boom, boom. So there's no intersection, only one intersection, right? So this is vertical line test pass. So this is yes, it is a function, right? And for this one, look, if I draw a line here, then what happened? Do you see 2 intersections here and there? So this graph does not pass vertical line test. So this is no, it's not a function because you have 2 intersection, right? So we talk about this one, function or not a function, right? And when you look at this, state the domain and range of each function. So you need to talk about, we can talk about the domain and range. So domain is your possible x value, range is your y value. So for this one, my domain is 0 and 3. So your x values, right? So 0, 3, that's my domain, and my range is y value, right? So 2 and 4, those are our y value. And 38, my domain, it is 1, 2, 3, right? So domain is 1, 2, and 3, and my range is what? Your y value, right? So do you remember domain and range? I just want you to remind what we learned before. All right, so range is what? All 5s. So you just have 5. We don't write 5 3 times, right? So we did this kind of thing. And the last review, evaluate each function for the given values of x. So we are evaluating function value. So I'm gonna do only one thing, guys. So x equals 1. Then what do? We plug 1 into x, or we substitute 1 into x. So f of 1 equals 2 times by 1 minus 6, like that. You just substitute x value into x. Then that is 2 times by 1, 2, minus 6. So that is negative 4. And for 45, I'm going to do it for negative 1. Alright, I'm showing this one only. So g of negative 1. So same thing, when you substitute a number, we need a parenthesis. Like this, over 3, and 2 times by negative 1. Negative 2 minus 1 over 3. Negative 2 minus 1 is negative 3 over 3. So you cancel, you get negative 1. Alright? So this one, do you remember that, guys? So just make sure you are fresh on this concept on your brain. Alright? So we talked about the function or not a function, vertical line test, finding domain and range, evaluating function value. Okay? So today we will do inverse relation. So, when we talk about the function or not function, all of them could be relation, right? So look at this. That's the relation, 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 relation. If x value is not repeating, then we can say that's a function, function. So all functions are relations, all right? So look, inverse of a relation. That means the inverse of a relation consisting of the order pair xy is the set of all order pair yx. So what do? X to y, y to x. You just switch x and y. So domain, look, domain of the inverse is the range of the original. The range of the inverse is the domain of the original. So literally we're just switching x and y. Right? So example, find the inverse of each relation, state whether the inverse relation is a function, state whether the inverse is a function. Right? So first of all, I'm gonna find my inverse of that. Right? So all you need to do is change x and y. So look, 1, 2, right? My x is 1, my y is 2, but for my inverse, you need to change your x, y. So 2, 1, like this. And my second one, you see 2, 4, change it, 4, 2. And your third one, to use it 3, 6, change it, 6, 3. And 4, 8, then what? 8, 4. Like this, guys. So that's my inverse. Alright, that is my inverse. And it says, state whether the relation is a function. Then to figure out function or not, then we need to check our x value. That's repeating or not repeating. So look, 2, 4, 6, 8. It's not repeating. So that's a function, right? Function. Inverse is a function. Your inverse is a function. Yes. Inverse relation is a function, right? And then what was my original, guys? My original was 1, 2, 3, 4. That was a function because no numbers are repeating, right? So that was, yes, 2. Okay. And for B, let's see. Let's figure out my original relation. 1, 1, 3, 4. So that's not a function. So that's just a relation. So let's think about the inverse of that. Let me change the color. So for this, inverse of B, then that is you change your x and y, right? So 5, 1, 6, 1, 6, 3, 4, 9, right? And then let's check that's a function or not. 5, 6, 6, 4. Is that a function or not? No, that's not a function. So not a function. So for this one, it was a function. Original was a function. Inverse is a function. For B, original was not a function and inverse is not a function, but there is no correlation for that. All right, so we will figure out. So that's an example. And then look at this. So also we have like a different way to represent a function. That's the other one. So you could have a graph, table like this, right? And then you want to find the inverse. So guys, this is the inverse notation here. We use -1 power, all right, like that. So that's original, that's inverse, okay? So that's original function, and that's inverse. So your x value is 0, y is -1. So you just change your x and y value, then you get -1, 0. And your second value 2, 0, so you can make it 0, 2. And 3, 2, so you can make it 2, 3. We're getting inverse right now. 4, 3, so you get 3, 4. Right? So there's a graph. So I'm gonna sketch the first one, my original function. So I'm gonna use original for this one, yellow. Okay, so let's see. Yellow. I'm gonna use yellow for the original. So 0, -1. So it's right here. Oh my god, you can't see this. Let me change the color. I'm gonna use green. Okay. 0, -1. And 2, 0. It's right here. And 3, 2. It's over here. And 4, 3. 4, 3 is here. Right? So you get this 4 points, and now I'm gonna plot inverse function. All right, so -1, 0, so it's over here, and 0, 2, it's over here, 2, 3, it's right here, and 3, 4, it's over here. Right, so we get this. Another 4 points. And guys, you know what? Let's draw a line over the graph like this one. So look at this, guys. So if you draw y is equal to x, then that's symmetric. So original function and inverse functions always symmetric over the line like that. All right? So relation and function. So because you know what, relation was what? That could be anything. Relation could be any ordered pair. Right? That could be relation. And for a function was domain so or x value cannot be repeated. Or you can also say for one x value you have only one y value, or x value has only one y value. Right? So each domain value has one y value. So that's the relation and that's the function. Right? So when you move on,